Hello, everyone, and welcome to our webinar on our 2024 Dependency Management Report. My name is Darren Meyer with Endor Labs, and joining me today is my colleague Henric, who has been the primary author on this Dependency Management Report. And we're going to cover our findings, and we'll make sure that we get you a good link to the report, which is available online or as a PDF without registration. With that, take it away, Henric.
Yes, hi everybody. Very happy to have you here. So first of all, we were not able to squeeze all the insights and all the charts into this report. So please feel free to look up the other details and more information by browsing the website, downloading the report and so forth. All right, so let's jump right into it. So we start just for setting the scene with a picture you have seen in the past a couple of times already. So this is a dependency graph of the Graph Maven plugin. It's an arbitrary component which we always use to kind of illustrate where we are in terms of open source based software development. So on the very top of this dependency graph, you have the first party code, a component developed by some vendor, and all on the bottom below you have all the third party components that provide reuse functionality or so. And of course the motivation is clear. The first-party developers do not need to reinvent the wheel over and over. So this picture you see here is basically more or less the same for all the different ecosystems. Sometimes you have more, sometimes you have a smaller number of third-party components, but the ratio overall is very comparable, I would say. Now, those of you having worked with STA solutions, you know very well that there are a lot of vulnerabilities popping up in all those third-party components, right? And then those number of vulnerabilities can really overwhelm the developers or the AppSec people needing to deal with them. And so the first thing that we looked at for this year's dependency management report was to look at different criteria that you could use for giving priority to different vulnerabilities, right? Because you do not all of the vulnerabilities in all of those components you see here require the same, let's say, urgency for being resolved and addressed and so forth. So we basically had a look at all the vulnerability findings across our customer tenants in order to understand which of the different criteria serve better or do not serve so well for giving this priority. Let's start with one of the ecosystems, maybe the Java Maven world on the very left-hand side. And you see basically 4 different criteria. Whether vulnerable functions are reachable according to call graph analysis, whether a fix is available or not, whether a vulnerability is in a test dependency or not, and the EPSS score, whether it's greater than 1%. And if you look at those bar charts, you see that the best prioritization criteria are by far the reachable functions, right? So, which means you start looking at vulnerabilities where the vulnerable function can be reached, can be executed in the context of a client application. And the other very effective prioritization criterion is the EPSS score. And so if you combine those scores together, in case of Maven, if you combine actually all 4 scores, as you see here, you would only, you start by looking at 4.something% of the vulnerabilities. And it's kind of a comparable number for the NPM ecosystem, where you would look at 4.17% of the vulnerabilities first before going to other ones. And so yeah, I think this is a confirmation of data that we also already had in previous editions of the Dependency Management Report. Another data point that we wanted to look at is to understand which of the open source libraries cause most of the vulnerability findings in our customer tenants. So here we have one chart produced for the Python PyPI ecosystem, and it basically shows that the 15 components that are responsible for most of the vulnerability findings add up to 74% of all findings, right? So the other way around, if you were able to upgrade those 15 components to non-vulnerable versions, you would be getting rid of 74% of all your findings. The numbers are comparable for Java and NPM, a little bit smaller though. Example components are cryptography or Pillow in the Python ecosystem. And if we go over to the Maven Java world, we see that Jackson Data Bind is the component which brings in most of the findings. 22% are only because of Jackson Data Bind.
Yeah, I want to jump in for a second, Henric. To me, this is part of the story of why this is so difficult for AppSec to get things updated, right? Because if you look at these things and what they are, even especially in Maven here, you're looking at the top two are Jackson Data Bind and SpringWeb, right? Which are kind of notoriously annoying to update. And it's very difficult to set an organizational standard and have everybody stay up to date on these things because they're such framework components. And so it's really hard to stay on top of these, even though this is where most of your vulnerability lives.
Yeah, completely agree here. And this is exactly what we are going to look at in the next section of this presentation, of this webinar, which is all around breaking changes, right? So breaking changes are basically syntactic or semantic incompatibilities between the version that between two versions. So the one that a developer is on, that is currently used in an application, and the next one that he wants to upgrade to. And those breaking changes could result in basically compile time or runtime problems. Compile time problems, maybe if you use and call an API function, which suddenly does not exist any longer, well, then your code doesn't compile any longer. Or in other cases, you would only discover such incompatibilities at runtime. So we looked, so those numbers here are all for the Java and Maven ecosystem. And so we looked at the 1250 update paths related to the 15 components you have seen on the previous slide. So update path means we looked at all the vulnerable versions that exist for those 15 components and which have been produced since, I think, 2017 or so. So we imagine a developer would be on such a version. And then for every such version produced in this time frame, we would look at, well, how do they come to a non-vulnerable version? What would they need to change? Would they need to increase the major version, the minor version, the patch version, or the build element of the version identifier? And so this is relating to SAMGRAP, SAMGRAP being a versioning convention, which developers or development projects use to convey information about whether a project, whether a component introduces or not such breaking changes. So so here the SAMVER is typically composed of a major version element, a minor, a patch, and sometimes a build version element in this identifier. As you see here in the case of Jackson Data Bind, major version would be 2, minor version would be 13, and so forth. And depending on what version which element of the version identifier the developers increase, consumer can they basically convey to consumers whether this new version introduces a breaking change or not. So if a major version is increased, this is clearly indicating a backward incompatible change according to SAMWare. If a minor version, a patch, or even a build element change, this basically should be backward compatible. And so with this explanation in mind, looking at those upgrade paths for all the versions of those 15 components, 1250, in basically 24% of the cases, in order to go to a non-vulnerable version, developers would need to update the major, which is implying a breaking change. In 28% and in 47%, they would need to update the minor or the patch element of the version, which should be in theory backward compatible. Now, we looked at how frequent are those, which of the different breaking change types, how frequent they are. So there are different ways an API or a component can break a client. The most common change is basically the deletion of a function. So a function which was formerly present has been removed. Obviously, the client calling into it is breaking. So this is, as you see here from the pie chart, by far the most prevalent, the most frequent breaking change that we found when comparing all those versions, which is in line with the research such as from Ochoa and colleagues, which came to the same conclusion basically.
Yeah, and I think this is another great example of like why upgrading is hard, right? And I want to clarify a little bit, like, and correct me if I'm wrong, but when we talk about these categories of breaking changes, these are sort of like potentially breaking changes, right? This is not 85% of the time they've removed a function that you're necessarily using. So it's true that like most of the time when you upgrade, this doesn't bite you, but it could.
Exactly, you're completely right about this. So a component could have thousands of functions, right? And then maybe from one version to the other, they just remove one or a couple. And this only breaks a client if that client is really using it in some way or the other. Which brings us back to our basically code-centric approach, where we use program analysis techniques to understand whether a breaking change between two versions really impact the client. So this is, from an approach point of view, comparable to this prioritization criterion that we have seen before. You have a function somewhere in a component which is vulnerable, and we try to understand, is it in fact reachable? Does it matter in the context of a specific application? And the same idea underlies this breaking change analysis.
Right. Because without that, you're kind of stuck just hoping. You got to put the change in, and then you got to hope that your tests catch whatever the problem is.
Exactly. So even if you knew, in most cases, you do not even know which functions have been changed or removed. But even if you knew, you would still not know which ones matter for me unless you perform this analysis. Okay, now you learned a little bit about these SAMware versioning convention, versioning standard, a little bit about breaking changes and change types. Now, I think the most important takeaway of this section on breaking changes is this slide, which is in parts confirming what SAMware is meant to convey as an information, but in other parts, very importantly, it's not basically in line with the ideas of SAMware. So let's start with where our observations match to the idea of SAMware. So you see in this bar chart that basically how many times, or whether and how many times there are breaking changes or no breaking changes in major versions, minor patch and build version updates, right? And starting from the left, you see that 100% of the major version updates do introduce breaking changes, which is perfectly aligned with this idea of SAMware, right? You increase the major version identifier to convey the information there is breaking change. And then on the right-hand side of this bar chart, you see that in 100% of the build the updates where the build version element is changed, there are no breaking changes, which is also again in line with the ideas of SAMware. Now, the problematic part is in the middle of this bar chart, where we see that in the case of minor updates, 94% of the minor updates do contain breaking changes, which is a lot, and which should not happen according to if the people followed strictly SAMware. Again, it doesn't mean that a function change or a function removal here from one version to the next minor version really affects you. this is to figure out through that you need to figure out in the ideal case through a proper analysis, in the worst case by in fact running into the problem in your production environment, which is of course not advisable.
And of course, part of this problem is that some people are trying to use SemVer and just are imperfect about it. And some people are using version numbers that look like SemVer, but they're not actually following the practices. And there's no way to know from the outside, really.
Exactly. Yeah, I agree. I think overall, there are some kind of empiric studies that show that overall the adoption of the SemVer standard is increasing over time. But it's true, it's hardly, or it's not always clearly communicated. So if you go on a project page, they would not say we follow SemVer or we don't follow SemVer. I don't think this is frequently communicated on the project website, so you kind of you're left to guessing whether this is the case or not, right? And so here, even in the case, and this is maybe the last takeaway from this slide, even in case of patch updates, still 75% of them contain at least one breaking change. Again, whether it impacts you as a client is to be clarified. All right, so this concluded the bit on breaking changes. The second part of the presentation is all around vulnerability databases, mostly, I would say. So, and in order to introduce this topic, I would like to start with a slide that is very important when it comes to assessing whether a vulnerable function in your dependencies impact your application, your client code or not, right? And in order to perform such a vulnerability assessment, you basically go from the application code all the way down to the vulnerable code in order to understand, is there any vulnerable code present in the first place? And can it be executed in the context of my application? So this is the reachability analysis that you hear so frequently about. And this reachability analysis is basically a proxy for the question whether a vulnerability can be exploited. But since answering the exploitability of a vulnerability is so difficult, you require a lot of context information that is not readily available in a machine-readable way during development time, which is when most or many STA tools run. We basically answer the easier question, whether something is reachable, executable in the context of an application. Well, and to answer those questions, the typical way of things is that you have your application, you try to understand what are the components and component versions used by this application. This is mostly, or I would say predominantly, done through manifest files, right? So through declarative dependency declarations, but not always. You may have heard what we have called phantom dependencies, which is when dependencies are established in other ways than manifest files. But we will not discuss this today. What we are going to discuss today is basically the other parts of this chain, right? So once assume you're sure about the component version in use, you can go from there to the vulnerability, because vulnerability advisories typically say which are the components and component versions affected or not affected by a vulnerability. And then you require code level information, meaning what are the functions that are affected by the vulnerability. And so we are going, in the next couple of slides, we are going through kind of the difficulty, and we highlight some of the problems when it comes to maintaining this high quality, accurate vulnerability databases, which is a very, just difficult work. It got a lot better over the course of the years, especially thanks to OSV, which is aggregating a lot of other vulnerability databases, but it's still very labor intense and many times error prone. Okay, so let's first look at discrepancies between different databases. So here we basically looked at OSV, the open source vulnerability database. They aggregate, I think, more than a dozen a dozen other public vulnerability data. You can consume it through the UI or through a REST API. And all of that, again, is great, much better than the situation 5 years ago, where we didn't have all this, where we were predominantly consuming NVD when it came to security advisories. But still, we looked at the different sources of the open source vulnerability database, and we noticed there are some discrepancies that happen, right? So on the left-hand side of this bar chart, you see vulnerabilities reported for the Python component TensorFlow, which is by far the kind of component having the most reported vulnerabilities in the Python ecosystem, more than 400 for the three components, TensorFlow, TensorFlow CPU, and TensorFlow GPU. And we just did a comparison against the GitHub advisory database, where we noticed this difference of round about 40 or so vulnerabilities for the TensorFlow CPU and TensorFlow GPU components. GitHub has fixed this very quickly after we have reported this discrepancy. And this is just to highlight that there is a lot of manual work when it comes to processing those vulnerabilities and kind of maintaining which are the affected components. And there are a couple of phenomena that play into this, such as projects producing multiple artifacts from one open source repository, forking, rebundling, and a couple of other phenomena which makes it difficult to track what are the affected components. And this goes as far as you see on this bar chart. So what we do here is we basically looked at our own proprietary vulnerability database and compared the affected packages of the advisories with the affected packages reported by OSV. And we found that in 72%, only in 72% of the vulnerabilities, we agree on the affected packages. So both Endor and OSV report this identical names, let's say identifiers of affected packages. In other cases, Endor would report more, OSV would report more, and sometimes there's a certain intersection. And again, this is due to these phenomena mentioned before, kind of forks, multi-module projects, rebundling, and so forth. Sometimes even we notice that not only package names are missing, but some vulnerabilities lack entire, miss entire ecosystem. So here we have one example. I think it is a Microsoft component. They produce artifacts for 4 ecosystems out of 1 open source repository on GitHub or so. And the GitHub security advisor we found is not talking about the NPM package being affected, even though the original advisory from Microsoft does.
I definitely don't want to people come away thinking that we're trying to say that like OSV is bad or anything either. Like it's an extremely valuable resource. I think it highlights really just how hard this problem is, right? That, places like NVD and OSV, like there's a lot to tackle. There's a lot of human decision making in those processes that can lead to mistakes. It can lead to differences of opinion. It can lead to things being missed or accidentally included. And so like it remains at the moment really important for individual vendors in the vulnerability management space to focus and do extra work on things that are within their scope and their area of relevance. But that doesn't diminish the value of OSV. Like we start with it as well, right? And we just enrich it.
Yeah. No, I completely agree. And I do not want, you to leave with this impression. To the contrary, there's a lot of improvement that happened over the course of the last 5 years, both with OSV, which is just an aggregator, right? They do not do any manual work on top. This manual work is done from the source databases aggregated by OSV. And also the GitHub guys are doing a great job here. And I think one of the biggest improvements that I think we saw in the last couple of years is this introduction of the PERLs, this package URLs, right? Which after all, use the ecosystem specific identifiers to name the affected components. Because before that, in the pre-Perl area, we were just relying on the CPEs associated to common vulnerability, to CVEs, and they were just hugely inaccurate. So things got a lot better, but it's just a very hard problem, which we just need to tackle as an industry, I think, to improve this overall situation. Right. Then another bar chart that I find quite insightful is, for this reachability analysis, as well as for this breaking change detection, we basically, mostly for the vulnerability impact assessment, the reachability analysis, we require to know, what are the vulnerable functions in the different versions of the affected open source components. And because this is kind of the fuel that powers our code-centric solution, right? And this chart shows just how seldomly this information is available in the public databases, the public vulnerability databases. So again, you see this per ecosystem. Let's have a look at Maven. We see that in 57% of the cases, there's no code level information at all. In 42% of the cases, we see that there are commit references, meaning we have the commit identifiers, the commits, the fixed commits, those that were done by the project maintainers to overcome a vulnerability, and you can infer the affected functions from those. In 0% of the cases for the Maven ecosystem, you have function references right away. So in OSV, the schema allows you to maintain information about affected functions, but for Maven, this is rarely ever done. It's a little bit higher for some other packages, but still, very low numbers. And so this is kind of the status quo when it comes to code level information in the public vulnerability databases. And it just kind of explains very well why all the different or many STA vendors in this space, they build their own proprietary database on top of the public vulnerability databases to maintain this information, especially if they perform some program analysis in one way or the other, right? Which in some way hinders also the development of open source solutions, because the proprietary databases are not public, obviously. And so the open source projects do not have the same fuel, so to say, to drive their open source solutions, to develop code-centric approaches themselves. All right, and the last here is just to emphasize something that is maybe known to many of you already, which is that there are, of course, the coverage gaps. We have seen this a little bit in regards to TensorFlow before. This is across multiple ecosystems, and it shows that some ecosystems are better and other ecosystems are not so well covered by the NVD in terms of CVEs, right? And I think the one to call out here on this chart is the NPM ecosystems, where 460, roundabout 459 vulnerabilities do not have a CVE alias, right? So which is important if you, for your vulnerability management processes, basically, that to make sure that if you use NPM, Node.js for your applications, you cannot only rely on NVD for receiving vulnerability advisories. You would miss out a great share of advisories, basically.
Fantastic. And Henric, I just want to make a note of time. We wanted to make sure to leave some Q&A time. We're hitting up at about the 30-minute mark.
Okay. Now, I think this, in fact, was my last slide. Perfectly in time for once. Doesn't happen often. And so let me go through the 3 takeaways of the session, right? So the first takeaway was to show that function level reachability and EPSS scores are the most effective prioritization techniques. They let you focus on those things that matter most, and this is the ones that you should start, dealing with in your applications. The second one is, the second part of this presentation was all around the fact that developers cannot just update, right? Which is maybe sometimes suggested by AppSec people. They would just say, look, you run a vulnerable one, there's a non-vulnerable, well, as easy as that, just update to the non-vulnerable version. And it's not easy because even minor and patch versions do contain breaking changes. Whether they matter for you, a given application, is another question, which can be answered with help of programming analysis techniques to support better upgrade decisions, right? To make more informed decisions on whether you take the risk of updating or not. And the last takeaway is around the public advisory databases. Just some of the, we were really just touching on high level on different problems, discrepancies, coverage gaps, and so forth, which is, I think, an industry-wide problem that everybody should know about. So I think this concludes my talk. Darren, any other feedback on any of those takeaways?
There's a lot here. I had the privilege of looking through and kind of helping you edit your work for this report, and there's so much here. I really encourage people to check out the full report and really understand just how complex this necessary security task really can be. And I'd like to open the floor to our attendees as well to kind of pick your brain, ask some questions. But I wanted to say thank you for taking the time today, and I really appreciate it.
Indeed. Thank you so much.
All right. Really appreciate you taking the time to do that with me, Henric. I actually wanted to, we haven't had any questions from the audience at the moment. And I do want to let our audience that's tuning in live know that we do have a Q&A. Please feel free to ask any questions in the chat, or there's a Q&A section. We'll try to get to them the best that we can. I also have pushed out a notification for you. If you want a link to the report, you can just go ahead and click that button. There's no email required or anything like that. You can just read it on the web or download the PDF for you to read offline at your convenience. I kind of wanted to ask you, Henric, like you talked about kind of some of the challenges of open source solutions to doing dependency management. And as a developer myself, and I'm sure as a researcher, I really value open source solutions to things wherever I possibly can. And what do you think you'd like to see from the industry in support of a more open solution, or at least progress on an open source solution to some of these dependency management problems?
Yes, great question. I think one of the biggest obstacles is really kind of the vulnerability databases, all those discrepancies, coverage gaps, and so forth, and the fact that we have all those different proprietary databases being maintained in parallel with very little visibility for customers to understand which one is better or worse, and kind of seeing through all this. So I think one great improvement would be, as an industry, to spend effort on building a proper vulnerability database with code level information. I think one way to get there is for all the code hosters to basically make it very easy for the open source project maintainers to say, this is the fixed commit, or this is a vulnerable function. Because right now, this information is not coming from, or very often not coming from, the project maintainers, but from people further downstream trying their best to, spending a lot of money and trying their best to get this right. So I think this would be a very important step.
And the places where you report things are usually not asking for it very clearly either. Like it might be an optional field somewhere, or it's not really being encouraged. It's not being asked for in bug bounty programs and so on.
Yes, but I think a good, I do not want to call out individual kind of market players, but GitHub obviously is a very important one, right? And if I'm not mistaken, they have this feature in order to let people kind of secretly work on security patches, to not make them visible from the start to just everybody, to the public, And I think if you have this secret security fix development, this is exactly where you could also ask for, well, then highlight the fixed commit, because this is, where it's ending up anyhow. So I think it would be very simple steps, making the life of many people downstream easier.
Yeah, 100%. And I think part of it is on the reporter side, because a lot of the security researchers that are finding these flaws, there's a huge variation in like ability to read and understand source code, right? There's a lot of security research that you can do without actually having to program or know how to program, because you can test things from outside and be like, I can make this bad thing happen, please fix, right? It's often up to the maintainers to then do the code analysis part of it and figure out like, okay, why can you make that thing happen? So I think there's kind of a call to action a little bit for researchers to, if possible, try to, do a little bit of that themselves. We do have a question in the chat for you, Henric. Anthony's asking us if you have any observations around proprietary software vulnerabilities.
Yeah, that's a difficult question, because I'm working on this open source vulnerability for so many years, and there's little, comparably little information shared for the proprietary vulnerabilities, at least to my knowledge, right? So here you would, I guess, primarily consume the data from NVD, and then you have, as a customer of the respective proprietary product or service, you may get additional information. But I don't have so much visibility on this. My guess would be the information you get from the vendors is very different in quality also, depending on whom you talk to. But I don't have any really kind of empirical data around proprietary vulnerabilities.
Yeah, and this is a problem kind of across the industry, right? Like we're not super great at information sharing in security now for over 20 years. And like it's gotten better, but there's still a lot of resistance to, especially private entities, sharing details about vulnerabilities, sharing details about security posture, details about breaches, anything that kind of helps the industry as a whole do it. Like it's very hard to get a hold of that data unless you are an important customer of theirs. And even then, like there's a lot of resistance to that data sharing for various reasons.
Maybe one observation that I made many years back in terms of open source vulnerabilities also applies to proprietary software. When I started on this whole topic, we were primarily relying on these CPE identifiers that come with CVE advisories in order to, and then try to understand, well, this CPE, and this is how still many solutions work, those that focus on metadata. And so they try to map those CPE identifiers to the software component names in their bills of materials or in their manifest files and so forth, or dependency graphs. And I guess this is still the same approach for proprietary software, would be my feeling. So this, what I mentioned in the talk, this significant improvement in the open source world, where the package URLs were introduced, and after all, the advisories were annotated with the same package identifiers that are also used in the different package managers and ecosystem. This improvement, I'm not sure whether it happened to the same extent in the space of proprietary software. My gut feeling, but this is nothing more than that, is that maybe here you still rely more on the CPE to software component name mapping.
Yeah, I mean, most proprietary packages are not in any kind of like package repository. There's some exceptions, but generally speaking, it's, go download, or it's in an app store, right? And there hasn't been that kind of standardization for proprietary components. I think the upside of that, though, is I remember from previous research, which I think you confirmed in, I believe it's last year's, correct me if I'm wrong, but like a huge percentage of your average proprietary app is open source components anyway. So like a lot of if you get the open source stuff right, you've taken a big chunk out of this problem, this capability. You just have to know, maybe it's through SBOMs, maybe it's through some kind of independent analysis. You have to know what those components are in the proprietary thing to find out if they're affected, right?
Yeah. I mean, I think maybe software IDs would be one way, but they're not maintained again for the advisory. So this is where I see is the big problem, mapping the advisories to the different components, whether they are open source or whether they are proprietary. And so if they,
Yeah, absolutely. And like there's not really strong incentives for private organizations to do that work. So it really kind of ends up falling on places like, GitHub Advisory Database and National Vulnerability Database and things to do that work. And they've already kind of got too much on their plate, right? So it's an interesting problem to try to solve, to try to create those incentives to get the participation of the industry players, to say like, hey, there's value to the community of being a little bit more open about when you have a vulnerability. Like, you can't have complex software without vulnerabilities. So like, let's be open about it. Let's share data. But that's a big cultural change.
I think, but this gives me now all the bigger software vendors, at least they are CNAs, right? So they are CVE numbering authorities. So they can basically decide themselves about whether there is a vulnerability or not. And I think in this context, they can also enrich metadata such as the CPE identifiers. And it would be interesting. An interesting study would be how consistent the CPE names given by the different CNAs belonging to the software vendors are in naming their own products. It would be an interesting study.
Well, maybe in next year's report we can try to answer that one.
Yeah, or maybe there are some researchers around listening, willing to dig into this chunk of data to figure this out. I mean, there have been so many studies around, looking at NVD data, but I can't remember having seen something around naming consistency also from different CNAs and the like. I think this could be interesting.
Absolutely. So I haven't seen any other Q&A from our audience, and we are coming up on the time that we allotted for this webinar. So I think probably our best strategy, unless you have any closing remarks, would be to give people a few minutes of their time back. All right. So I'm gonna put up the link a little bit more prominently for the downloading of the report. I encourage people to go read the details. There's a lot of detail there. And I'd also like to point out that we do have other sessions like this. If you find this kind of material interesting, we do sponsor a community called Lean AppSec. You can go to leanappsec.com. We have an upcoming live event talking about basic AppSec concepts. It's not branded. It's not kind of vendor led. It's something we do to give back to the community. So you'll be seeing a lot of people from across the AppSec community who have done a lot with a little, and kind of fought against the limited resources they have to accomplish good AppSec programs and solve AppSec things in their organization. So I encourage folks who have that to sign up, express some interest, come join us, come hang out. If there's things along those topics that you'd like to talk about, I'd very much welcome you reaching out to me on social media. I'm Darren P. Meyer pretty much everywhere, including LinkedIn. So please reach out, please sign up, please join us.
All right. Thank you. Have a great day, wherever you are.